Today's lesson is going to be a review on fractions and understanding like the basics of fractions. So the first thing that we're going to do is we are going to draw out a shape here, a nice little circle. Move it around a little bit, and I'm going to draw out a rectangle. We're just going to talk about what these mean precisely. So if I drew a line here and I cut the circle into two pieces, this says it is one part. Sorry, this is two pieces now. And then, let's move this guy over here. What if I colored one part of this red? And I kind of said it already that this is one part. I'm going to write that up here. So that means that this whole circle is of two pieces. So I say this, that it is one part of two pieces, or it is 1 over 2. So this red blinking straight across, that if it is shaded in like this, that tells me how many parts are colored in, and this tells me how many pieces the shape has been cut into. So we say one part of two pieces. Okay, what about this one? Let's divide this into fifths. And then I'm going to color 3 pieces. So this says 3 parts have been colored, and there are 5 pieces that the shape has been divided into. That's another key word, that dividing one, because it's going to hint to us that this line can also be interpreted as something else. So this changes to 3 over 5, so 3 parts of 5 pieces. Okay, so then that changes, let's say kind of more general, that the numerator over the denominator is the same thing as saying the part and the whole. The next thing that we're going to look at is we're going to just quickly convert fractions to decimals. I have a section on this in the worksheet, and you can just plug it into your calculator to figure out what the decimal value is, but I'll definitely give you a bonus point if you do the long division. So for instance, if I had the fraction, let's say 4/5, and I didn't know what that one was offhand and I needed to convert it into a decimal, I can change this into 4 divided by 5. 4 fits into 5 once. Oh, I did that backwards. That should be 5 on the outside here. So 5 into 4. 5 does not fit into 4, so we put a 0 there, and we add a decimal, and we add a new 0. So does 5 go into 40? Yeah, it goes in 8 times exactly. So 5 times 8 gives us 40. We subtract. This gives us 0. So 4/5 is equal to 0.8. And that comes from the idea that 4/5 is the same thing as saying 4 divided by 5, and it's the same thing as saying 0.8. These are all equivalent terms, which is the next thing that we're going to talk about. We're going to talk about equivalent fractions. So definition time. I shorten it like this. You don't have to. You can write out definition total. So this says equivalent means equal. So that means that these guys are going to be equal in some way. So let's draw out some circles. I'm just going to kind of layman's term them. So I got here, here, and let's go like this, I think. Yeah, just pretend they're even. I'm not very good. Let me actually retry this one. I really don't like the way that one looks. Yeah, that looks a little better. Okay, and then I'm just gonna, I think I can rotate it. Oh, that looks even worse. Let's keep it like that. Okay, so what this comes down to is before I said that this was one part over two whole pieces. Sorry, it's one part of two pieces. And then if I color here, this is two parts of four pieces. And this is three parts of six pieces. Now, if we look, we can kind of see that these are all equal just from the way they look. But if we wanted to do like the math portion of it, so if I said, okay, I want to check and see if 1/2 is equal to 2/4. Well, there's a few different ways that we could do this. We could check and see if I can get 2 to 4 somehow. So I need something that I'm going to multiply the top and the bottom by to get to 4. Well, if I go 4 divided by 2, and that is equal to 2, that means I can multiply by 2 here and here, and that is how I get this answer. So I have to use this in both spots. Now I can't go from 2/4 and get 3/6, not very cleanly. So you kind of have like a home base fraction, and in this case it's the 1/2, and I'm going to check and see if it's equal to 3/6. I'm going to do that same thing. I'm going to say, okay, 6 divided by 2, that's equal to 3. Well, if I multiply the top by 3 and the bottom by 3, oh, that works. Yeah, so those are equal. The other thing that we can check too is that 1/2 is equal to 0.5. 2/4 is equal to 0.5, and 3/6 is equal to 0.5. So what you have to make sure to do is you can also check those fraction bits. So let's do kind of a more concrete example here. So the example we're going to do here is 3/4 is equal to blank over 16. What I'm going to do is going to 16 divided by 4, which is equal to 4. So if I times by 4 here, I have to times by 4 up here. So the number I'm missing is 12. And you can check 3/4. Oh, I don't know what I was trying to write there. Is equal to 0.75. And 12/16 when you plug it into your calculator is equal to 0.75. All right, the next thing that we're going to do is we're going to compare fractions. So when we compare fractions, sometimes it's hard to see which one is bigger or if they're equal. So if I drew this out, it's really hard to see, especially because you can't divide a circle into fifths, I don't think. Um, or at least it's not as easy as dividing it into rectangles. It's really hard to see which one's equal. Even if I drew out this guy into a rectangle, and I said that's probably about half, you can kind of tell, but you don't know for sure. So how do we compare fractions? Well, they need to have the same denominator. So they need the same denominator. And this will be really useful for next day when we are looking at adding and subtracting fractions. So I have an old method that I like to use. You don't necessarily have to use it, but I call it the smiling X. And I learned this when I was in school. It's it's supposed to be used for adding and subtracting fractions, but it is also an easy way to find the common denominator. So if I have 1/2 and 3/5, and I want to find the common denominator, I multiply these two together to get my new denominators. Then I slide this guy here. So 1 times 5 is 5, and 2 times 3 is 6. I don't know what I'm writing there. 2 times 3. So then we can see that 5/10 is less than 6/10 because we read it this left to right. So we say is less than 6/10. I have a bad habit of just saying that 6/10 is greater than 5/10, but that's not really reading it the right way. It would work if I had it flipped the other way, but just read left to right knowing that the mouth is always trying to eat the biggest one. Okay, we're going to do an example of converting mixed and improper fractions, and then we'll be done for the day. So we're going to do an example of mixed to improper. So if I have 3 and 1/4, notice how I'm saying that 3 and 1/4. So I have 3 wholes and a quarter of a new whole. So if I want to change this to an improper fraction, I need to take my denominator, multiply it by the whole value, so 3 times 4, which gives me 12. And then I need to add the 1 here. So this gives me 13/4, knowing that the denominator stays the same. It's really just kind of remembering that process. And then let's say if there was like a negative out here, I'm just going to do like -2 and a ninth. This negative, I don't even worry about it. I just throw it out there for now, and I know it's going to be in here after. So I kind of just get rid of it. So I'm going to put that, ignore the negative. When calculating. Numerator. So then this just becomes, I'll do this in a different color. This is just 2 times 9 plus 1, so 18/19 over 9. Let's do improper to mixed. So we're going to do, let's do 19/4. So the question we have to ask ourselves is how many 4s fit into 19? So what is 19 divided by 4? What is the first like value that fits into 19. So then we go 4, 8, 12, 16, 20. So this is too big. 16 works. So that is 1 4, 2 4s, 3 4s, 4 4s. So if I've already taken up 16 here, we just have to go 19 minus 16, and that gives us our number right here. I'm going to circle them in red so you know where it came from. The other way that you can do it is you can divide and just see what the number is for the whole value and ignore the decimals. So like let's say I had 5 over 2. So if I go 5 divided by 2, I know it's 2 point something. I don't really care what this little bit is, but I know at least 2. So that 2 gets to come over here. The 2 down here stays the same, so 2 times 2 is 4. 5 minus 4 is 1. And I'm going to circle that this time in green. So either way works, whichever way makes more sense for you.